Hello everyone, welcome to the another video of this software engineering video lecture series. In this video we are going to take a look on software architecture. In architecture we are going to split in two videos. First we will look at this first part. In this lecture we will cover the core ideas of software architecture including models, design principles and common architectural styles. By the end of this video you will understand how architecture shapes software systems and influences their quality. Let's begin. Designing a software system starts with understanding the requirements. From there we create an architecture that defines how the system will work. This includes decision about the user experience, the internal structure, and how the program will be implemented. In reality, the design process is often iterative. As we design, we learn more about the requirements, which can lead to adjustments. This feedback loop help us refine the system to meet user needs and the technical constraints. Good design follows a few important principles. You can see in the slides. The first one is simplicity. Always aim for simple solutions. Use modeling and abstraction to break down complex problems. Simple design are easier to implement, test and maintain. Usability. A well designed system should be easy to use correctly and hard to misuse. This principle ensures user satisfaction and reduces errors. Cou- Coupling and cohesion. Aim for low coupling and high cohesion. Low coupling means subsystem depends on each other as little as possible. High cohesion means the parts of a subsystem are closely related. Together this makes system easier to understand and modify. What is architecture? Software architecture is about making big decisions early in a project. Let's look at three perspectives. According to Fred Brooks, architecture is about maintaining conceptual integrity. A system that follows a consistent vision is easier to use and maintain. Ralph Johnson describes architecture as the shared understanding that expert developers have of a system. It's the big picture everyone works towards. Ian Somerville highlights that architecture strongly influences non-functional characteristics like performance, security, and reliability. In short, architecture sets the foundation for how a system works and feels. Understanding architecture requires thinking at different levels of abstraction. First one is requirements. The highest level answers what the system should do. Architecture. This level bridges the gap between what and how, defining the system's structure. Program design focuses more on the how, detailing modules and functions. Code, the lowest level of abstraction where specific implementation happens. Each level builds on the one before it. moving from broad goals to detailed execution. Architectural models are visual representation of a system design. They typically include diagram and specifications, multiple perspectives, appropriate detail. Diagram and specification. The diagram provides a visual summary, while specification explains the details. Multiple perspectives. This includes the conceptual view, what the system does, static view, its structure, dynamic view, how it behaves, and physical view, how it's deployed. Appropriate detail. A good model is concise and fits on one page while still being informative. Models help teams understand and communicate the architecture effectively. Subsystem divide a system into manageable parts, each with a specific role. Decomposition. Breaking the system into subsystem improves understanding and simplifies design. Coupling. This refers to dependencies between subsystems. Too much coupling makes the system harder to change. Cohesion. This measures how closely related the parts of a subsystem are. High cohesion means the subsystem is focused on a single purpose, making it easier to maintain. There are many architectural styles, but here are four commonly used ones. First one is client or server. The client and server operate independently, communicating through defined protocols. Either side can be replaced without affecting the other. Second one is layered architecture. The system is divided into layers, with each layer provide services to the one above it. This style is common in applications with a clear separation of concerns. Pipe and filters. Data flows through a series of processing components, each transforming the label, each transforming the data. This style is great for data processing pipelines. The last one is repository. Subsystems share data through a central repository. This requires careful management to ensure data consistency and support atomic transactions. This is all from this video, and I hope you all of you got understand, and stay tuned for the next video lecture series, and thank you.